Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to add, subtract, and multiply radical expressions. So let's get right to it. First, let's talk about a concept called like radicals. Like radicals are radical expressions that have the same index and the same radicand. Let me repeat that. Like radicals are radical expressions that have the same index and the same radicand. And only like radicals can be added or subtracted, similar to combining like terms, okay? If you remember, combining like terms, you have to add the coefficients. Well, it's very similar for combining like radicals. You're going to simplify the radicals first, then you're going to add the coefficients of the radicals, and you're going to keep the same radical and the same radicand, okay? For example, 3x plus 2x is 5x. That's an example of like terms. Like radicals look like this. 3 square roots of 6 plus 2 square roots of 6 gives me 5 square roots of 6. So it's that simple. Let's get right to it. 3 square roots of 5x minus 2 square roots of 5x gives me 1 square root of 5x, which can just simply equal square root of 5x because the 1 is invisible. 6x squared square roots of 7 plus 4x square roots of 5. I can't do anything with that because they are not like radicals. 12 cube roots of 7xy plus minus 8 fifth roots of 7xy. Can't do anything with that either because they're not like radicals. Yes, they have the same radicand, but they do not have the same index. So they are not like radicals. But 17 fifth roots of 3x squared minus 15 fifth roots of 3x squared does equal 2 fifth roots of 3x squared. Again, when they're like radicals, you simply go ahead and combine the coefficients and keep the radical and the radicands identical. In other words, the same. I have 5 cube roots of x plus 3 plus 15 cube roots of x plus 3, which gives me 20 cube roots of x plus 3. All right. Now, sometimes they're not always going to be in simplest form. So before you can just say, yes, they're like radicals or not, you have to simplify them. So for A here, none of these are like radicals yet. But I know that 12 breaks down into 3 times 4. The square root of 4 is 2. So I got 2 square root of 3. 75, I know that's 3 times 25. 25, the square root of 25 is 5. So that's 5 square roots of 3 minus the square root of 3. Now I have like radicals. So 2 square roots of 3 plus 5 square roots of 3 minus 1 square roots of 3 will render 6 square roots of 3. The cube root of 250 can be broken down into 2 times 125. The cube root of 125 is 5 with a cube root of 2 left over. 54 can be broken down into 2 times 27. The cube root of 27 is 3. So I have 3 with a cube root of 2 left over. And 16 can be broken down into 2 times 8. The cube root of 8 is 3 with a cube root of 2 left over. And those are like radicals. So 5 cube roots of 2 plus 3 cube roots of 2 minus 3 cube roots of 2 gives me 5 cube roots of 2. All right. The cube root of 54x, I can break down 54 into 2 times 27. And the cube root of 27 is 3. 3 times this negative 5 will give me negative 15. With a cube root of 2 left over. And then I can't take out any x's. I only have one x in a cube root, so I can bring that next to it, and that x inside the cube root stays the same. Over here on the second one, I've got 7, okay? 2, I can't take out a 2 from the cube root, but 3 goes into 4 one time, and I have 1 x left over. And I have that 2 as well. So, okay. So now, here's a conundrum here. I have the cube root of 2x, and I have the cube root of 2x. But I cannot add these coefficients. So what would happen here is I can factor out a cube root of 2x. That means I divide it to both terms, leaving me with the cube root of 2x times 7x minus 15. That's as far as I could go there. Because once again, I cannot add 7x's with negative 15. Okay, fourth roots. We're looking for sets of 4. So this is 2 and 16. The fourth root of 16 is 2. So I got 2 with the fourth root of 2 left over. And this is 3 and 16. Fourth root of 16 is 2 with a fourth root of 3 left over. They are simplified. They have the same index, but unfortunately they do not have the same radicand. So that is my answer. I cannot add those. They're not like radicals. Okay, so how about when we're multiplying radicals and also polynomials made up with radicals? Well, we're going to distribute and we're going to multiply and use FOIL just like regular numbers. And we're going to use our radical skills. So we have 3 times the square root of 6, and then minus 5 times the square root of 6 times the square root of 6 equals 6. So I have 3 square roots of 6 minus 30. Let's go over that real quick. The square root of 6 times the square root of 6 equals 6. Why, Mauro? Well, we've talked about this before. The square root of 6 times the square root of 6 is the square root of 36, which equals 6. You could also think about it as the square root of 6 times the square root of 6 is the square root of 6 squared. So the power of 2 cancels out the radical. Okay? You can also think about it, the law. Square root of a value times the exact square root of the same value will always equal the inside value. It's that simple. Okay, next. 3 times 5 is 15. 3 times square root of 7 is 3 square roots of 7. Negative square root of 7 times 5 is negative 5 square roots of 7. And negative square root of 7 times negative square root times 6 square root of 7 is negative square root of 49, which equals negative 7. Combined like terms, I've got 15 minus 7 is 8. And I've got 3 square roots of 7 minus 5 square roots of 7 gives me negative 2 square roots of 7. All right. 3 times 2 is 6. 3 times 4 square roots of 5 is 12 square roots of 5. 2 square root of 5 times 2 is 4 square roots of 5. 2 square root of 5 times 4 square root of 5 is 2 times 2 is 8. Square root of 5 times square root of 5 is square root of 25, which equals 5. 40 plus 6 is 46, plus 16 square roots of 5, adding like terms and like radicals. And last but not least, please remember that that power of 2 means that I am multiplying 2 square root of 5 plus 3 square root of 2 times itself twice. Now we could go the long way, or we can use the square binomial theorem that we know. First term squared. So the first term is 2 square root of 5, and we're going to square it. Plus 2 times the first term times the second term, there in pink there, plus the second term, which is 3 square root of 2 squared. It's that simple. So 2 square root of 5 squared, that's 4 times 5, which is 20. Plus 2 times 2 is 4 times 3 is 12. Square root of 2 times square root of 5 is square root of 10. And then 3 square root of 2 squared. 3 squared is 9 times 2 square root of 2 squared is 2, which is 18, plus 20 is 38, plus 12 square roots of 10. And there you have it. Now we know how to add, subtract, multiply radicals. Thank you very much. Hope you learned a lot and come back anytime. Take care now. Bye-bye.